So today our topic is stereometry. It's the branch of the chemistry which deals with the relationship relation between the product and the reactant. Like it involves different laws in it that help us to understand the relationship between the reactant and product, like uh, their ratio of combining with each other and which element combine with how much of the proportion. Like there are definite proportion of the elements to combine with the other element due to their chemical properties. And the first law we're going to discuss is the law of conservation of mass. We all have already heard of this law, and it's as it says, and I think we are at the level like we understand the conservation of mass. The mass conservation of mass simply says, and it is a popular law in the whole science, like mass can neither be destroyed neither be created, right? Or neither, but can be only transformed from one form to another form, right? And then that, how does that apply to the chemistry? Like let's say a reactant product A, I mean a reactant A and the reactant A B, what it will form is AB. And let's say it have 1 gram and the B is also 1 gram. The mass, the reactant's gonna be 2 gram. It's not possible that we give 1 gram of this reactant and 1 gram of this reactant B, and we are getting only 1.5 gram. Like it's neither possible due to this law, and it's not possible in fact also. Like and now uh, from this law we come to the chemical equation. Like to understand, let's take a example of the chemical equation. Let's say hydrogen and there is a oxygen, like, and we all know that these two combine to make the H2O, right? And H2O, and let's see here we have the one two hydrogen atom to combine with the oxygen to form the two hydrogen and the oxygen, and hence there is a two hydrogen here. Like we keep two hydrogen here to balance out the equation. Oxygen is always O2, right? Oxygen is always O2, and then we keep to balance oxygen with O2, like we keep here 2, and then hydrogen is gonna be 4, so we keep 2 here, right? I hope you understand. Like I myself is a student applying the Feynman technique to learn things. Like I hope I remember what I have uploaded on the YouTube videos, and hope you understand the law of mass conservation. And then second law we have law of definite proportion. uh, like law of definite proportion uh, usually comes with the idea of like certain amount of like certain amount of elements combined with a certain amount of the other element. In the world H2O, if the H2O is forming, it will combine with 1 to 8 ratio, like one hydrogen and the other oxygen is 16 if you remember, and the hydrogen H2, then we have 2, and then 2 ratio comes, then we come to 1 and 8. That's all. Like if the water is forming, it will be combining on 1 and 8 ratio. And that's a law of definite proportion. And we comes to the third law, which is law of multiple proportion. And it was proposed by the Dalton. Like we know who is Dalton, and verified, or and then verified by Berzelius. Like all these law were proposed by the other scientists and then re-verified by the other scientists, because they were discovered very in a era like 1774 AD, where there was not so much technology to be verified. Like scientists were not that evolved like we are today. And then time passes, like other scientists came verifying things. Science was just so much debate, enough far behind in the history. And what we are talking about, the law of multiple proportion. The law of multiple proportion talks about that the formation of more than one compound by two element, let's say oxygen, and then with combine oxygen also oxygen and carbon combine, to form CO, like carbon monoxide, and the same element can combine to form CO2. And so what is the ratio here? The ratio is a whole number LH. And then carbon is combining, like let's say carbon is say 3, and then there is 16, 3, 1 and 3. Let's ignore this. Like we will discuss law of multiple proportion in the next video.